Hi, in this video, we want to take a look at multidimensional scaling, specifically unfolding. All right, so what we're going to do, we're going to use multidimensional scaling to look at N judges who rank M stimuli, and we're going to try and see, hey, what does each judge prefer? And also, which stimuli are more similar or by preferences? All right, so we're going to be running through some example code from Modern Psychometrics with R. Here is the GitHub page for where I got the code. It's a good book. You should check it out. All right. So what we're going to do, we're going to have N judges. So here we're going to be having students and then or people responding on a test, and then M stimuli, which is the class of questions. And we're going to try to figure out preferences, and we're going to try to figure out which stimuli are more similar to each other. We're going to try and see which subjects are more similar to each other. All right, so let's go ahead and load our data set. All right, we're going to take a data set of 327 people who responded to 10 variables. And the data set is the dissimilarities between the people. So we have, of the 10 variables, we've got power, achievement, hedonism, stimulation, self-direction, universalism, benevolence, tradition, conformity, and security. All right, so here we're loading the data set from the Smackhoff package. It's individual values. And here, what I want to just get a feel for what does the data look like. So I'm going to go ahead and visualize things using ggplot. I need a for the purpose of ggplot, I need to have it in long format. So I'm using the gather function from the tidyr package. And here I'm just setting up the order of the data by so that the power and conformity and security, I'm ordering those by their averages, so it's a little bit easier to interpret. This is something I do for work all the time. So here what I'm doing is I'm taking each individual field of data, I'm taking its average, and here I'm sorting each field of data by their average. And so when I plot this, we know that benevolence has the lowest average, power has the greatest, and we can just see that the averages shift from left to right as we go through the plots. And these are all pretty relatively close to bell curve, so that's looking good. So let's go ahead and start working on unfolding. Now, this first example I'm going to go through is not from the textbook. This is one I'm using to kind of make it a little bit easier to interpret when I say, what is unfolding? What is this preference modeling using multidimensional scaling? All right, so the big idea here is that the judges, the people that are closer to each other, have more similar preferences. The stimuli that are closer to each other are interpreted as being more similar to each other, and judges prefer the stimuli that they are close to. All right, so what we're going to do, we're going to take the unfolding function from Smackhoff package. Now here, I'm going to go with interval data. We could have gone with ordinal. There are several types of data that are available on this. The two major ones for applications are going to be interval and ordinal. And here, I just want a line for this as our first initial example. I would not honestly launch this model, but it's good to show bad models so that people, the viewers know what a bad model looks like. So let's go ahead and run it. And so here's our stress value of 0.35. This is our goodness of fit measurement. Here is the number of, or here's the penalized stress and number of iterations. If I have a lot of iterations, it's a sign of a bad model fit. And so now here, I'm just extracting the information to plot. So here, this is going to be the judges are pulled off of our unfolding model in the row aspect, and then columns gives us the stimuli, And here I'm just, doing a little bit of data prep. And now I'm visualizing it. All right, so what we see is that the blue are the judges, the people taking the test. We can see that we've got two groups, very solid. Now, on this plot, the points are like on top of each other. It's hard to see exactly what the distribution is. So I went ahead and put a box plot here. We can see that, a fourth of the data falls between the median and the 75th percentile. And 50 percentile, 25th percentile, we can see that 25% of the data is in here. So things are pretty clumped up on top of each other. We've got one extreme outlier up here, and then here, we see the power is the lowest, then security, benevolence, hedonism, can't read these, simulation, then tradition. All right, so what this says is that overall, according to this model, everyone's number as a group, overall, everyone's most important aspect is going to be security. Now, this group here has a stronger preference for benevolence, hedonism, stimulation, and tradition than the people in this group. These people have a higher preference for power than these over here. This person here, they're definitely an outlier. They're more concerned with tradition than anyone else. Now, I don't like how these are so stacked on top of each other. Looking at this, I feel like this would be a case to merge benevolence, hedonism, and stimulus. All right, so benevolence and hedonism, I really don't feel like those line up that well. I honestly don't like this model, so I wouldn't use it. And this was not from a textbook, so I feel like the author would agree with me. All right, so let's actually talk about the Smirnov method. All right, so in rectangular Smirnov modeling, the rectangular refers to the fact that we have a rectangular matrix of the similarities. And we're going to have stress. So the sigma is the stress, where x1 is the row configuration, x2 is the column configuration of our data. Here is our distance measurement. So once I choose a method to define distance, this is a fixed value. Then the multidimensional scaling comes into play here. And what we're going to do in this example is that we're going to do multidimensional scaling to take our data, which is 10-dimensional data. We want to represent it as well as we can within 2 dimensions. So the goal of this multidimensional scaling is to take the 10-dimension distances and as much as possible preserve those and put the individual dots on a 2-dimensional plane. And this will make it easier for us to interpret what's going on because I can't see 10 dimensions. All right, so the stress is just the difference between our model and our data values squared and add up, standard sum of squares. Now, notice something about this is that in this configuration, the distance aspect does not have to be symmetric. That's if I had a really special project, the distance between item A to item B can be different than the distance from item B to item A. That's okay in this configuration. I looked up like the Wikipedia page and looked up some journals. Most people don't talk about this asymmetric distances, but here R gives us that option. Now, if I want to set up my distance to be the standard Euclidean distance, then I'm just going to take the difference between individuals and square it and sum it up. Just the most natural thing we could possibly do. All right, so now let's do our 2-dimensional unfolding. So now the default setting in the unfolding function is to have 2 dimensions. So previously I had n dimensions equals 1. Need to keep on going up. So n dimensions equals 1. That's to put it on a straight line. I like that as an initial look because that sets it up as straight lines makes it easier to kind of figure out things. because it's just a line. It's as simple as possible. Now, with default settings of number of dimensions equal to 2, I'm going to run it. And now, here is our stress value. Here is our penalized stress. I really prefer penalized stress for this purpose because I have different dimensions. Automatically, if I increase the number of dimensions, I'm going to have more flexibility in my multidimensional scaling. And so the stress value will, unless something weird happens, it's going to go down. If I had 3 dimensions, I could have multidimensional scaling that kept everything to a 2-dimensional plane within three dimensions. And so the regular stress has to go down as I increase the number of dimensions. So I want to use penalize to get a better comparison. So here it's a better model according to this goodness of fit. And so here, let's go ahead and do some plots of our model because I like them. I like the model so far. We're going to do the confidence plot. We'll do a shepherd, and then we'll do a stress plot. So now here's the confidence plots, or sorry, configuration plots. Configuration plots. And this is similar to a biplot. So we can see each individual on the plane plotted down, and we see kind of in a circular manner each of these aspects. So we see security, conformity, and tradition coming together. Okay. Then benevolence, universalism, self-direction, hedonism, achievement. Can't read this one. And then power. All right. So the author of the textbook looked at this. The author of the original study, Schwartz, looked at that and said, you know what? I think I can model this with a circle and have all of the different fields of my data along a circle. So let's go ahead and do that. Oh, well, here's our shepherd diagram. So here we see the dissimilarities and the configuration dissimilarities divided by the d hats. So it's not a perfect line, but it's looking pretty good to me. And now here we can see which field does not fit as well. So here are the individuals. And here are the fields of the data. We see that benevolence had proportionally gave very little stress. So we see that these ones are fitting with our model very well. But now hedonism and not security, what's close to hedonism? Achievement and self-direction. All right, so yep, I'm not real sure which one is here that is cut off, but we can see that these are the ones that are contributing the most to the stress, and this is indications that this model may not fit that well for these particular fields of our data. We also run a row permutation test. So here, using random permutation of the data, we can do a hypothesis test. We see that our p-value is statistically significant. So I'm going to go ahead and accept this model and proceed because it's statistically different than the shuffling of our data. Our shuffling of our data would be like a random, meaningless model. This is significantly different than that. Therefore, I conclude that I have a good model. And here we can plot the individual values. Or here's the stress values, here's the probability. And this is coming from the perm test. So here, these are this is the cumulative distribution function, the empirical cumulative distribution function from the permutations. And here we can see that our value is super, super small on that gray, the solid gray line. Let's check residuals. That's misspelled. That should be an S. And here I'm just plotting the residuals. So here we can see that we've got significant residuals going on here. Now let's fit a circle to the model, and here we're going to use the Smekhov function, fit circle, taking the output from our unfolding function. And here I'm doing data prep for ggplot. And so here I like it, it's the same circle, but it just looks a little bit different. And so here, what this would, so in this model, how I would interpret this is that what we would do is that we would put down achievement, we would interpret it here along the circle, hedonism here, stimulation here, self-direction here, universalism here on the circle, benevolence, it's practically right there, conformity, tradition, security, power. And then to judge similarity, we would go by the angular difference between each of our fields of data. And so here we could see that to judge hedonism, it would be the angle from self-direction. If I want to check security, I would take the shortest angular difference between any two. And then each dot, we would use proximity to the location on the circle to judge where the judge is closest to, what their preference is. Now, we can also do this. We can modify this. We can do circular unfolding by just modifying the code a little bit. So if we put circle equals column in our function, we can, set it up so that we can force the configurations to be on a circle. And we can also do row conditional unfolding. All right, so what row conditional unfolding will do is that this will remove the assumption of homogeneity between individuals. All right, so why would we want to do this? Well, we know that there's cultural biases, not cultural biases, but cultural differences in responding to items like this. And so we want to have the flexibility to go, you know what, somebody from this culture and somebody from this culture, they don't have a homogeneity assumption. I know that there's a difference between them. And so by using the conditionality equals row, I'm allowing for people to have different backgrounds. Now, a warning about this. This sounds great. This sounds wonderful, but this makes the model more complicated and it greatly increases computation time by a lot. It increased computation time by a lot. I was really surprised. So let's go ahead and work through this. Here's our stress value, pretty small, but you'll notice that the penalized stress shot up because it's a more complicated model. And you'll notice that there were a lot of iterations. So now when I do the plot, all right, so now I still see kind of a circle going on, but now people have shifted heavily. Like there's been a lot of shifting in this. Power and tradition are off by themselves. These are kind of forming a line. Now they're on a circle, but I can see the circle more clearly. They're all pretty tight. So would stimulation, achievement, self-direction, benevolence, universalism, and conformity, like stimulation is like closer to security. Does that really make sense? I'm not really feeling love for this model on this data set. Here's the Shepherd diagram. It's just gobbledygook. It's just too much. Here we can do the row and column stress proportions. We see the self-direction fits very well on this. Once again, hedonism doesn't really fit that well on it. And here is the plot. We're using ggplot just make it a little bit prettier. And so here is the circle, but I'm just not really feeling this. And the circle was refit on the data. So this is the new circle. Thing fit on that, and this, to me, this just doesn't make sense. All right, well, that's all I've got for you. Take care and goodbye.